Yeah. All right. So here we go. All right. So number one, since I forgot Live and Trey to record for a second, since the limit does not exist at g of x, taking it times 2 has no effect on it, so the limit does not exist. Number two, as we're going towards 3 from both directions, it's going really close to, everybody said 10, and 10 was the right answer. All right, and now we're here. Okay. The limit as x approaches 2 is negative infinity. Which graphs agree with it? Does A agree with it? Yes. Does B agree with it? No, because as it approaches from the left, it goes to negative infinity. As it approaches from the right, it goes to positive infinity. So B is not it. C? No. It's just A. Okay, piecewise function. Okay, so we got a piecewise function here. So to figure this out, we stick negative 3 into both of these. Okay, if we stick negative 3 in here, we get 6 over 2, which is 3. If we stick negative 3 in here, 3 squared minus 6 is 3. Since they are the same answer, at that point where the graph splits apart, they are on the same point. So yes, it is continuous at negative 3. We good with that? Okay. Of course, we'll have one of these on here. Okay. So what's always the first step? Direct substitution. And then we're going to factor on this one. Don't say no idea. You should have an idea. It is factor. X and X, X and X. This is minus and minus, 6 and 4. This is plus and minus, and 2 and 6. So the X minus 6 is cancel. And then what do we do after we factor and cancel? Direct substitution again. Do we find the answer? Yep, we'll find the answer. So direct substitution, then factoring, then we go direct substitution again, and limit found. Oh, indeterminate form is in there. Yep, indeterminate form is right after direct substitution before factoring. Thank you. Okay. Got it? So there would be 5 of them there. All right. What could you do here? Graph it on your graphing calculator. Absolutely, because I wouldn't want to do this really to any other way, but I can do it another way by putting a 2 in. What is 2 over 1 minus 2 minus 2 is 0. What's the cosine of 0? 1. And so then we get 2 over 0, which means there's an asymptote there, right? Okay. So we got an asymptote going on. So if we would try a number bigger than 2, because let's say 2 is right here, but a number bigger than 2, like 3, what's the cosine of 1? Well, the cosine of 1 is like, what's pi divided by 2? It's 1.5 something, right? So the cosine of 1 is somewhere in the first quadrant. What's cosine in, oh, but then I need to know the exact, yeah, I'd graph it on the graphic calculator. Because that's going to be hard to know if it's positive or negative there. Yeah, it's going to be kind of hard. So somebody, graphic calculator, really quick. Goes like this. Okay? So since it goes like that, then it's positive, positive. Okay? Graph it on a graphic calculator. Sine of 2x, that's one of my favorites because I remember that one, which is 2 sine of x cosine of x over cosine of x. Well, the cosines cancel, so it's 2 sine of pi over 2. Sine of pi over 2 is 1. 2 times 1 is Okay? Now, trig identities. I suppose I should list the trig identities on, oh, they're right there. Thank you, Kate, for pointing that out for me. All right. So, what's the limit as x approaches -2 of g of x first? Where's g of x? Well, it's right here. As we approach -2, what is it? 0. So then we have to find the limit as h approaches 0. What do we have going on here? Does not exist because it splits right there. Okay? We good? Okay. Oh, this is one of our favorites. We're going to rationalize the numerator on this one because we stick a 1 in, we get 0 over 0, which is indeterminate form. So rationalizing the numerator is square root of 5x plus 4 plus 3. Square root of 5x plus 4 plus 3. So then we get 5x plus 4 minus 9 over x minus 1 times the square root of 5x plus 4 plus 3. So it's 9x minus 9. Whoa, no, it's 5x minus 5 over x minus 1 times the square root of 5x plus 4 plus 3. So I'll take out a 5 and the x minus 1. So it's 5 over the square root of 5x plus 4 plus 3. So if we stick in a 1, we get 9 there. So it's 5 over 3 plus 3, which is 5, 6. For this one, the only way I would ever do it is by graphing it on the graphing calculator. Okay? Well, I guess I already know the answer because when the higher power is on the bottom, what is it? 0. Okay, higher power on the bottom is 0. But still, you might want to graph it in a graphic calculator. All right, as we go towards 6, can we figure out the answer of the limit? No, there's too big of a space in here. Plus, we should be going down to smaller intervals of numbers. The table isn't appropriate because the increments of the x values are constant. They should be actually going down to a smaller number. Okay. Oh, here's a fun graph. Select the x values which g has an infinite discontinuity. What's an infinite discontinuity? Where there is an asymptote. Where do we have asymptotes? -2 and a +3. What about this 2 here? What about this horizontal line? Why don't I put that down? Because it's a horizontal line. And when we do limits, we're dealing with x values, and that's a y equals line. So, yeah. So there we go. All right, so here's a continuous function. This must be the intermediate value theorem, right, Kate? So, if we're in between -2 and 1, does there have to be a 2 in there somewhere? Well, we look at the y values. In between 2 and -1, do we say that there has to be a 2 in there? No. In between -1 and 0, does there have to be a 2 in there? Yes. In between 0 and 1, does there have to be a 2 in there? No. So it's just -1 to 0. That's the only place. Okay, what's a reasonable limit as we get to 7 for an x value? As we're going towards 7, what's a reasonable limit? -6.5. Okay, right down here. Not that. That's not the limit. It's where it is as the line approaches it. Okay. Hey, here we go again. One of these. What's h of -3? H is continuous. So I think we have to rationalize the numerator, right? So it's going to be x plus 12 plus or minus 9 over x plus 3 square root of x plus 12 plus 3. So this is x plus 3 up here, which cancels out. So then there's just a 1 on top. If we stick a -3 in here, we get 9, which is 3 plus 3, which is 1/6. Everybody agree? Okay. Is this continuous for all real numbers? It looks like this, people. No. Is this continuous for all real numbers? Yes. So it'd be G only. As we go towards, whoa, be back. As we go towards -2, what does this become? -10. As we go towards -2, what does that become? -2 cubed is -2 times -2 times -2, which is -8 minus 2, which is -10. Okay? Since they both go towards -10, what's the answer? -10. All right. What's a reasonable limit as x approaches 3 from the left? You got to make sure you see the negative sign on there. Negative as x approaches 3 from the left. -1 would be a reasonable answer for that one. -1. Which expression agrees with the graph? As we approach -3, is the limit 3? As we approach -3, is the limit 3? No, it's -3. As we approach 3 from the right, is the limit 1? Yes. As we approach 3 from the left, does the limit not exist? No, the limit exists. It would be -3. And it's not none of the above, so it's just choice B. All right. This one. Do we have a limit from the left and the right or from the right and the left as we go towards -4? Yes. Does the limit exist at -4? Is G defined at -4? Is G continuous at -4? So it's just the first two. Find the limit as x approaches -3 for that function. What would you do? Put in the graphing calculator or factor. X plus 3 is canceled, so we get 4x over x plus 1. Stick in a -3, we get -12 over -2, which is a +6. What's the limit as sine approaches pi/6? Ooh, Anna's looking at her unit circle, and she comes up with 1/2. Very good, Anna. That's why we have a unit circle, just to check things like that. All right. Any place it's continuous. Is it continuous from -5 to -2? Or -5 to -2 is yes. What about -5 to 2? No. How about -2 to -3? With a bracket there. -2 to +3 with a bracket there. No. If it had a parenthesis, it would be continuous. But with a bracket, it's not. So it would be none of the above in this case. All right, the limit as x approaches -2 of the g function over the h function. What's the g function's limit at -2? 5. What's the h function's limit at -2? 1. What's 5 divided by 1? 5. What's a cosine of 0? What's a cosine of pi over 2? 0. Can we use the intermediate value theorem to say 0.8 is somewhere in between there? Yes. Because the function is continuous and the numbers on the end have been met. Okay, intermediate value theorem. What's a reasonable limit as we approach -1 for this function? -3. Okay, that was one of our first problems, one of our first finding limits. Okay. What's the limit as h approaches, or as x approaches -infinity for the h function here, for this whole function? As we go towards -infinity, what's the limit? -1 is the y value as we go this direction. Okay? As we go towards infinity, what's the limit? 5 up here. Okay? Find the limit of this. Well, we get rid of these. The square root of 16x to the fourth is 4x squared over 2x squared is 2. And since we're going towards positive infinity, these are even anyway. But if they were odd powers, then you'd have to look whether we're going towards infinity or negative infinity. Okay. Can we use, what we're going for here is, can we use the squeeze theorem? Can we use the squeeze theorem in this case? No, because it crosses. No, it's incorrect because it's not true that one is always above and the other one's always below. Okay? All right. This, find the limit. This is as easy as it gets. What do? Plug in the number and we get -4 over 1. Hey, look, I got 30 out of 30 when I took this test. So hopefully you guys get 30 out of 30. Okay. So what we've got to do is we've got to decide how we're going to approach things next week. So this is my plan. Hopefully it works. Because 1, 2, 3, 4, 5 people are gone Monday out of here. So it only leaves us with 1, 2, 3, 4, 5, 6, 7, 8, 9. That is a majority. But what I was planning on doing is doing the review for the AP test, and then you guys taking the Khan Academy test on Wednesday. Or no, maybe. Hey, I got even a better idea. You won't like it, but I got a better idea. You guys take the Khan Academy test somewhere in between now and Wednesday of next week, as many times as you want, and you get what grade you get. And then Monday I review for the AP test, and Wednesday we take the AP test, because then we don't have school, we don't have this class the rest of the week, and then we can start out that next week with the new stuff.
Oh, because we don't have school Thursday.
We don't have school Thursdays, so Friday's a B day. So that's actually a better idea, because some of you could actually whip out this test between now and even the end of the period, possibly. But between now and next Wednesday, on your own, do the Khan Academy test. You can take it however many times you want, so you can score a good grade. Now, this is worth more points than the average stuff. So this is worth 100 points. The AP test is worth 100 points. Okay? The AP test you have to take totally solo, separated out in the classroom. This one, since it's at home, you can take with each other, by each other, for each other, whatever.
Never heard that before.
Well, you have to be logged in to yourself. So yeah.
So we're
So
reviewing-
Monday is a review for the AP.
So how do you expect us
Test.
to be ready for the AP test? Are you gonna record it?
Yeah, I'm gonna record it.
Okay.
Yeah, I'm gonna record it
Okay, I was
Monday.
gonna say.
Okay, so that's what we're doing. So hopefully Trey and Liv watch this video to the end because they got in on the discussion then. All right, bye Trey and Liv.